We're up to the final lesson of our systems of equations unit, and we're going to do a very quick review. At this point, you know how to determine which method will be the most effective when given the system of equations. So here are my thoughts. Graphing, definitely helpful when both equations are in the same form and I can create the line as long as I have graph paper. I know that seems obvious, so I didn't write it down. If there's graph paper, it might be helpful to graph as well. For substitution, I'm going to look for that y equals or x equals form so that I can substitute for one of the variables into the other equation. And for elimination, I'm looking again that both are written in the same form and I can quickly identify an opposite or create a zero pair. Now, these are just high suggestions from me. However, you can use whatever strategy makes the most sense for you. Another success point would be to be able to identify the number of solutions algebraically, as well as just by looking at the equations. You should be able to make an inference about the number of solutions and then justify it with algebra. And finally, we're going to look to see that you can accurately solve the system of equations. So these are the things I'm also going to try and model in this lesson. And make sure you're getting your practice and your feedback before the end of unit assessment. I'm going to use all three strategies to solve the system of equations. And then afterwards, I'll talk about when I have choice, which one I might use, like just what some of my thoughts are. But to be fair, you can use any of the three strategies and get the correct answer. There are just some problems that may have a faster solution using one strategy over another. So let's say I want to solve this system of equations using graphing. I just need 2 points, so I'm going to find the intercepts. And so I'll start by substituting when x equals 0. So my first point is 0, -3. And I'll do the same for when y is 0. X is 3/2 or 1.5. So this point is 1.5, 0. And I'm just going to graph one more just so I have another point in there. So another up 3. Just using the same slope. I just want up 3 over 1.5. All right, so I have this line. And now I'll do the same with a second equation. X plus y equals 3. So when x is 0, 0 plus y equals 3. So I have y equals 3. So 0, 3 is my first point. And my second point, let's give a little bit more space. X plus y equals 3. X plus 0 equals 3. So in this case, I have x is equal to 3 or 3, 0. I'll cross these two lines. And you can pretty much see the point of intersection right here at point 2, 1. So that's the system. Normally, if I was only using the strategy, I would go and I would substitute and check for if this was valid. I'm not going to do that for right now since we know how to check that algebraically. Let's move into substitution. And with substitution, what I look for is either a y equals or x equals. In this case, I don't see one yet, so I'm going to take the simpler equation. And I'm just going to subtract x from both sides to get y equals -x plus 3. And now I can substitute this into my next equation. Distribute. Combine like terms. And let's solve for x. So here I have x is equal to 2. And already, what do you notice? Same x equals 2 on this side. All right, now all I'm going to do is substitute to find what y is equal to. And y is equal to 1. So again, now I have another solution of 2, 1, which is the exact same from graphing. So we have it confirmed in 2 different ways. Again, the key here for substitution is to get that y equals or x equals, so we can just easily substitute in. All right, let's go to the last one, which is elimination. So what I'm looking for here is a term that will create a 0 pair when added. And luckily for us, right over here, we have a 0 pair. Now, if there was any other number in front, I could just figure out what would I multiply by to get a 0 pair. But here, I don't even have to do that. They cancel out. And I have 3x is equal to 6. X is equal to 2. And now I can substitute into another equation. 2 plus y equals 3. And y is equal to 1. So once again, there's my solution to 1. So there you have it, Math Marbles. Any different strategy is going to get me a solution here. So do I have preferences? I absolutely have preferences for this. I'll show you them in just 1 second, but hit pause and jot this down into your notes. Here are my personal preferences for different strategies. For graphing, I really enjoy using the graphing when I can easily create 2 points. And it also helps when I have graph paper. If you don't get graph paper on it, it's a little difficult unless you're using Desmos or some type of graphing tool. Otherwise, it may not be as accurate. For substitution, I really do look for a very easy x equals or y equals type form. That way it makes it very easy for me to go and sub in and solve algebraically. And for elimination, I look for those 0 pair opportunities. I also look to try and see, can I do it by only multiplying one term? And what I mean by that is there have been times I'll see something like 2x and let's say 5x. In this case, I'd have to multiply both of these by the inverse just to get what I'm looking for, a -10 and a 10. So that's what I look for, but I prefer if I can only do it one time. None of these options is impossible, but sometimes looking at one really lends itself to one strategy. Looking at the system of equation, I would most likely use substitution, and here's why. There's no graph paper. I'm not going to graph. I'm not going to estimate and get an incorrect answer. And I could do elimination. The only reason I'm not going to do elimination is because they're not in the same form. And I am going to choose substitution because I already have x equal to an expression. So there's an easy substitution to be made. So let's start x plus 3y equals 8. And now I'm just going to substitute 4y minus 6. Combine like terms and solve for y. Now that I have y, I'm going to substitute y equals 2 into either equation. and simplify. All right, so I have a solution of 2, 2. Let's check academically to verify it's a solution. So 2, 2 works for the first equation. And 2 works for the second equation. I think the biggest takeaway for me is I'm just looking for the path of least resistance, which is the one that can get me to the answer in the least amount of steps. And of course, that's my logic and thinking. But if you have a strategy that you feel the most confident in and that makes you more fluent, then by all means you can solve any system of equation with any strategy. Hit pause and jot this down into your notes, and I will see you in the next lesson, Math Marvels. Be well.